All right, hello, welcome. This is our first lesson of Algebra 2. We're going to start kind of with just a short, quick little review here. So, subsets of real numbers. So again, we've got our real number system. Okay, our smallest subset we're going to call our whole numbers. And if you remember, whole numbers are like 0, 1, 2, 3, 4, on and on and on and on. Next, we have our integers, which are positive and negative numbers. So like -2, -1, 0, 1, 2, and on and on and on and on and on. After that, we've got rational numbers. Okay. And rational numbers are numbers that can be written as fractions. So it could be like -1/3, or it could be 2/3, could be 0.75. Okay, that's not a fraction, but we could turn it to 75 over 100. So those are examples of real numbers. And then besides the real numbers, there's this whole category of numbers called irrational. And irrational numbers are numbers that never end and never repeat, like the square root of 2 or pi, okay? Pi never ends, it never repeats. So all rational numbers are integers, all rational numbers are whole numbers, but not all whole numbers are integers, not all whole numbers are rational numbers, and none of the rational numbers are irrational. So one thing we may have to do is graph real numbers on a number line. And again, that's not a problem. We can do that. So let's say that we want to graph -5/4 and the square root of 3 on a number line. So I'm just going to number it. Let's see here. -3, -2, -1, 0, 1, 2, 3. So I know that -5/4 is -1.25. So if I were to graph that, that would be about right here. I'm going to say -5/4. And then the square root of 3, if I use my calculator, the square root of 3 is approximately, let's say about 1.7. So I'm going to put that right here. Call this the square root of 3. So again, that's a skill that we need to have. Again, I was able to convert that fraction into a decimal, which helped me. This one, I had to use a calculator to find approximately the square root of 1.3. These squiggly lines, they kind of look like an equal sign, but they're squiggly. That means approximately. And as you can see, we have one number that's negative, one number that's positive. That is totally all right. The square root of 3 would be an irrational number, and -5/4 would be a rational number. And so sometimes what you have to do is you have to order them from least to greatest or greatest to least, which again can be difficult when they're in different forms. So let's look at an example. -0.2, 7/10, -1, square root of 2, and -4. Well, I know if I want to graph these or list them in from least to greatest, I know that -4 is going to be my smallest value. So I'm going to put -4 here. And now I have to decide, is -1 smaller or is -0.2 smaller? So I want you to think about, what is the distance from 0? Which one is further away from 0? And in this case, -1 is further away from 0, so I know that it's going to be smaller. Now all that I'm left with, I've got 2 left. I've got 7/10 and I've got the square root of 2. So I got to figure out, is the square root of 2 more or less than 7/10? And again, if I use my calculator, I find out that, hey, square root of 2 is 1.414, and it goes on forever. But 1.4 is bigger than 7/10. 7/10 is less than 1. So I know that 7/10 goes first, and then the square root of 2. And this number set is actually my largest number. Let's see here. To review some of our properties, okay, so let's review some properties. The commutative property should sound familiar, and that's talking about how order doesn't necessarily matter when we add or multiply, okay? So again, if I have an addition here, and then maybe I have multiplication here, A plus B equals B plus A. And that's the same thing if I do A times B, it's actually going to equal the exact same thing as B times A. Now the associative property is very similar, but this one uses grouping symbols, aka parentheses. So again, I could do A plus B in parentheses and then plus C, or I could do A parentheses plus B plus C, and I'm actually going to get the exact same answer. And it works the same way with multiplication. I could do A times B, and then I could multiply it by C, or I could do B times C first, and then multiply it by A. Either way, using the associative property of either addition or multiplication, I will get the same answer. The identity. So again, this one, it's almost so easy that it is hard to explain. All this is saying is that, hey, if I take A and I add 0, I'm still going to equal A. Or if I take 0 and I add A, it's going to equal A. Now, this one's slightly different with multiplication because anything times 0 is 0. However, anything times 1 equals that number. And let's see here. We have also got our inverse properties. So again, if I take A and I add it the opposite of A, it's going to equal 0. And if I do something similar like that with multiplication, I take A, I don't just take the opposite, I take the reciprocal, okay? I flip it upside down. These A's cancel out. And all I'm left with is 1. Of course, A cannot equal 0 because if we have a denominator of 0, it turns out to be undefined. All right, and then our last property, the distributive property. And I know I'm going kind of fast. Again, this is most likely review. You should have seen this in other classes. A parentheses B plus C equals, so this is where I have to take my outside term and I multiply it into each term inside my parentheses. So this is going to equal AB plus AC. That's the distributive property. So again, we might have to identify some of those. So here's 2 examples. Let's say I did 7 plus 4 equals 4 plus 7. The question might say, what would this property be? And again, if we look and we say, hey, I know that the order of addition doesn't matter, I would say that this is the commutative property. I'm just going to say prop of addition. Or B, if I did a different example, and I said, hey, 13 multiplied by 1/13 equals 1. This would just be the inverse property of multiplication. So again, you're going to have to be able to identify some of these. So let's do one more example. So let's say, how would we prove this? We're going to take A plus parentheses 2 subtract A equals A plus 2 plus negative A. All right, so this first one, what I'm doing is I'm really looking at the definition of subtraction, okay? Again, the definition of subtraction is adding the opposite. Adding the opposite. So let's just label this definition of subtraction. And then I could go ahead and flip-flop. So again, I'm going to keep everything the same over on the left side, but I could flip-flop this order. So I'm going to keep A outside plus, and then I'm going to flip-flop negative A plus 2. Okay, haven't really changed anything. This looks an A, not a 9. But now I can say, and again, this is the commutative property. Now I notice, hey, I've got an A plus a negative A. Okay, and that's where when we use the associative property, again, that's the one that tells us we can change up the order, A plus negative A, and then plus 2 on the outside. I'm going to see associative prop of addition. All right, I'm going to see that these guys cancel out, which is just going to leave me with 2, which again is what we were trying to prove, that, hey, when we get A over here minus A, we're left with 2 right here. So again, just using these properties to prove things that, again, some of us probably already knew. It's just putting language, putting math language into these problems. Another thing is unit analysis, okay? So again, turning like unit rates, changing up unit rates. So let's maybe do an example or two here. If I was looking at the problem, okay? So let's say you work 4 hours and earn $36. The question is, how much per hour? Well, if I made 36 total dollars out of 4 hours, I could divide 36 divided by 4 and find that I made $9 per hour. Let's do one more example. So again, kind of similar. You travel 2.5 hours at 50 miles per hour. How far did you go? Well, if I know that I traveled for 2.5 hours and I traveled, so I'm going to put this over 1 because I need a denominator, but I know that I traveled 50 miles in 1 hour. And again, I should have labeled this better because this needs to be labeled as 2.5 hours. Okay, I see that, hey, I have an hours label on the top and I have an hours label on the bottom. So just like when we divide anything, 2 divided by 2 cancels out. 5 divided by 5 cancels out. Hours divided by hours cancels out. So all I'm left with is 2.5 times 50, which gives me 125 miles. All right, so again, this is kind of leading us into like unit conversions. So again, you may have to convert miles to kilometers. You might have to convert ounces to cups. There's a lot of different things that you might have to do. So one example would be if we were driving, okay, from Montpelier, Vermont to Montreal, Canada. And that's about 132 miles. So again, we always start with our equation over 1 because 132 divided by 1 is still 132. That's what we're starting with. Now, approximately 1 mile equals 1.61 kilometers. So again, if I look at my problem and I say, hey, I have miles on the top, in order to cancel out miles, I'm going to put miles on the bottom, and I'm going to put 1 mile. But what's equivalent to 1 mile? Well, according to our conversion chart, it's 1.61 kilometers. So again, I'm not changing the problem because 1.61 kilometers equals 1 mile. What I put on the top has to be equal to what's on the bottom, even though they're different. Okay, because again, I'm talking miles and kilometers. So if I multiply across, I get 132 times 1.61, which is approximately 213. And then if I look at the bottom, 1 times 1 is just 1. So that kind of cancels out. All right, that's it for lesson 1.